To do that, we're going to define the idea of a ledger. This is a notion that comes from accounting, but for our purposes, a ledger is just a history of promises or transactions. So Alice gives $100 to Bob, Bob gives 47 to Mallory, and so on. It's just going to be a linked list of these blocks. But we can't put it as just a linked list in a program because then we turn the computer off or the computer gets stolen or something. So we need a more reliable way to form this linked list. The key idea is that what we're going to put in this block is not just the claim that Alice is sending $100 to Bob, but also a reference, a cryptographic reference, to the previous item in the block. So if all the history up until Alice gives $100 to Bob is represented by this hash code, then we can compute the combination of the new block entry and that hash code to get a new hash code. And then the next transaction, Bob gives $47 to Mallory, implicitly references the extended ledger by recording its hash code. And then we hash again those two pieces of information to get the latest ledger. So as long as everyone agrees on this hash code, it is infeasible to change what the history was. There's a small piece of information that everyone can see and agree on, and as long as this information is written in some reasonable place where people can go back and check it, then the history will be secure. Of course, we don't want just anyone saying that Alice is going to give $100 to Bob. We want to make sure that comes from Alice herself. So that can be done using our authentication mechanisms. Alice can use her private key to sign this promise to give $100 to Bob. So we will need to record in our blocks here the encrypted or signed transaction instead. We'll also technically need to remember that it's Alice's public key that you use to decrypt this record. And also, I'm using names like Alice and Bob here, but what do those names mean? We need some way of referring to individuals in a reliable way, and that's just another use of our public key infrastructure. So a more precise and realistic description of our blocks is that Alice signs the claim using her private key that whoever has the private key that goes with this public key promises to give $100 to Bob, but really whoever has the private key that goes with this public key. So you see there's not really any names Alice or Bob needed here, and that's the kind of anonymity that people have in mind when they're thinking about these chains of blocks. But it's not completely anonymous because any kinds of transactions that involve this key will be visible as correlated, right? Not individually anonymous transactions. So again, all we have to do is everyone has to agree on this latest hash, and that means we have this whole history of transactions, each individually signed by clearly identified parties.